Okay, we are looking at day 3 of our quadratics unit, and we are identifying quadratic relationships from tables of data. So we have this Angry Birds here, and we can see that there's a variety of parabolas here. So there's a low one that actually seems to make contact. I think the first one was the black one, the one at the top. And we could come up with the equation of this relationship, and it would actually allow us to figure out how high, so the height of the bird at any particular distance from the shot. So in order to do that stuff, we're going to need to be able to substitute into an equation in order to determine the output. So in other words, in this case, to determine the height. And the other thing we're going to do today is we're going to tell if we have a data or a table of values of a quadratic relationship. So we're going to be looking at second differences. The practice we're going to do today then will mostly be in class, and it will be filling out our Kaboom booklet, sections A to F examples, calculating the first and second differences once we have completed the data. And there will also be a handout with some data as well as some algebra, and you're going to give a reason for each thing as to whether or not it's linear, or whoops, that should actually say quadratic. Okay. So here I still have my Angry Birds, but I've put the equation over top, and I see that I actually have these 3 forms of the equations as we're used to seeing in our Kaboom booklet. So these are the 3 different forms, and in fact I'll tell you that this one is factored form, and we'll learn more about that tomorrow. This one is standard form. Again, we'll learn how to differentiate them tomorrow. And this one is vertex form. But any of these forms can be used to figure out the output. So that is, what is the height? And I'm finding height because that is the y-axis is height here. So I can find out the height if I know, in this case, the distance launched, because that's in the x side. So if I know distance from launch. So if I would like to know the height of the bird 2 feet from the launch, that means I'm going to be looking at 2 feet here, and I would like to know that output. I can estimate it because I do have a scale on here. It seems to be about a height of 1, but let's check. So I have the function, or the equation, y equals negative 0.05x times x minus 12. Well, if I'm talking about a distance of 2 feet, then I in fact want that to go in for both values for x. So I'm going to do y equals negative 0.052 times 2 minus 12. And then I just need to finish BEDMAS and calculate. Let's see if we can see that more. So that says then that I need 0.05 times 2 times negative 10, and I will type all of that into my calculator. There it is. So I'm going to multiply 0.05, which is negative, multiply that by 2, and multiply that by 10, which is also negative. So I have a negative times a negative, so I should be getting a positive answer. Let's see what we get. And I in fact get the value 1, which is what we predicted. So the point 2, comma 1 is actually what we're talking about on the parabola when we talk here. So we could put in any value for x. We could create a table of values, and so for example for 2 we know the value is 1. We could have tried the value x being 0. If we do that, I will do that into the standard form this time. When x equals 0, I have y equals negative 0.05 times 0 squared plus 0.6 times 0. Using BEDMAS, then I'm going to square first. So I have 0.05 times 0, add 0.6 times 0. Next I'll multiply 0 times 0 is 0. Sorry, 0 times 0.5 is 0, and 0.6 times 0 is also 0. So I wind up with the 0.00. Again, looking at that graph, yep, there's 0, 0 right there. So I can fill a little bit more out of my table of values. For the x value, 0, the y value is in fact 0. So if we look at example A from our Kaboom booklet, I have transferred the equations for A over to the inside page so we can see it very easily. I'm actually going to use the vertex form to substitute in because x only appears once there, so there's a little less work to do. But I always do need to remember to use BEDMAS. Alright, so here it says x is -3, so I'm going to write -5 times -3 minus 3, square that, and add 80. Then that really means -5 times -6 squared, and I add 80. So that's really -5 times 36, add 80. I'm going to need my calculator for -5 times 36. 5 negative times 36, and then I can just ask it to add 80. So plus 80 gives me the value of -100. So this is all equal to -100. I'm going to do the same thing again, but this time for the x value of -2. So -5 times -2 minus 3 all squared, add 80. So that's -5 multiplying -5 squared, add 80. So that's the same as -5 times 25, add 80, and now I'll use my calculator. So I have 5 negatives times 25 and add 80. And add 80. So this time I have the value of -45. I want to continue this all the way down through the table, please. This one's going to be really easy, so I'm going to do this one quickly. This is 5 times 0 minus -3 squared, add 80. So I'm going to do -5 times 9, add 80. This is -45. -45 plus 80 is going to be +35. So you can check a couple of those. Now the first differences are calculated by subtracting the thing that is lower in the table. So I've got -45, subtract the one that was up above. Subtract, -100. So subtract -100. So that really turns out to be -45, add 100, but you can type it into your calculator, 45, negative, subtract 100, negative, and we get the value of 55. So this is +55. And I also know that the value in x is -1, gives me a y value of 0. So my next first difference will be 0 minus -45. In other words, it'll be the value 45. And I can do one more first difference here. So I do 35 minus 0. In other words, 35. So the second differences are done the same way. So that is the lower in the table, subtract the one up above it. So I'm going to do 45 and subtract 55. And what I get here is -10. If I do these ones, lower in the table, 35, subtract the one up above it, subtract 45, again, -10. So what I'm noticing here is all of the second differences, if it is a parabola, so a parabola or a quadratic relation, will have all second differences the same. So we notice that all of the second differences as we fill out the table are going to be the same. Alright, so your work for the day then. After you have spent some time working on your examples, finishing example A, example B, filling out the table, and example C, then you're going to get your trig assessment task out and you're going to talk to your table. Your table is going to provide you feedback. Is the work understandable? Is the work organized? Do you have any recommendations? Did they use the correct formula? And are the calculated measures reasonable? Once you've spent time with that, you'll go back and finish the tables of values and first differences for your Kaboom booklet. And if you haven't finished graphing all of the examples, make sure you finish those with the iPad.